This is part 1 of the video, converting a quadratic function from standard to vertex form by completing the square. So given quadratic function in standard form, that is f of x is equal to ax squared plus bx plus c, we have to convert, or that is change it into the vertex form. That is f of x is equal to a times x minus h whole square plus k. So before going into this vertex form, we have to learn some basics again, like factorizing a quadratic function, and then we are going to look at what is this completing square. How do you complete a square from the function given in the standard form? Okay. So now we have a trinomial x squared plus 12x plus 36. You are asked to write this trinomial as a factored form. We call this as trinomial because we have three terms. First term is x squared, second 12x plus 36. Because of three terms, it is a trinomial. In this expression, you see 3, that's why trinomial. Now we are changing that into factored form. Okay, so given x squared plus 12x plus 36, how do you write it in factor form? We know that we have to have two parentheses, and we learned this earlier, that just write down the b term, like in this b, that is 12 here, over there that is the sum, I'll write 12 here, and what is the product? That is 36 goes over there. It's like a puzzle. We have to find two numbers whose product is 36, and the sum on adding those two numbers, the sum must be equal to 12. So I have written this 12, that is the second term's coefficient, I should say. 12 is written there, and the constant term 36 is the product. Now what are the two numbers? We can guess that 12 and 36, the factors of 36, known factors are 6 times 6 is 36, 6 plus 6 is 12. Right, the condition satisfied. I'll write 6 as my first number. Second number is also 6. So 6 plus 6 is 12, and 6 times 6 is 36. So I have my factors. I'll write here x plus 6 times x plus 6. So we can see the simplicity here. 12 becomes 6 and 6. That is, you have taking half of the 12, that was 6. And 6 times 6 is 36. Something special about these two factors, x plus 6 and x plus 6. Because those two are same factors, it is repeated. I can just write down x plus 6 whole square. Okay, so x squared plus 12x plus 36. This x squared plus 12x plus 36, I can rewrite as x plus 6 whole square, which is telling me that x squared plus 12x plus 36 is a what? It is a perfect square. It is a perfect square trinomial. That is, this expression x squared plus 12x plus 36 can be written as a product of two same factors. That's the reason we have it x plus 6 whole square. So in this case, we are able to write x squared plus 12x plus 36 as x plus 6 whole square. Hence, it is a perfect square trinomial. Let us look at one more example quickly. Let me say we have here x square plus 10x plus 25. It is obvious, right? It's 10. I have 10 here. 10 is the sum of the two fact numbers, and 25 is the product. Half of 10 is 5, and 5. 5 plus 5 is 10. 5 times 5 is 25. So, I can write this x squared plus 10x plus 25 as x plus 5 times x plus 5, that is x plus 5 whole square, right? Therefore, this x squared plus 10x plus 25 is a perfect square trinomial. Also, now you can see that x squared is the first term. So I'm seeing x here in this perfect square, x plus 5 whole square. And this 25, on writing this in the factored form, 25, that 5. 25, you know that it is 5 square, so you got 5 over there. Even in the previous case, x squared, so in the factored form you got x as the first term here. 36 became 6 because 36 is a 6 square. Therefore, we have a formula here, perfect square trinomial. This, any trinomial of the form of a square plus 2ab plus b square can be written as a plus b whole squared. Right? The example already we discussed just now. The first example, that was x squared plus 12x plus 36. That was x squared. 36 is a 6 square. I am writing the last term. And in the middle it will be 2 times that a is x and b is 6. So it is equal to x plus first and the last, that is x plus 6 whole squared. Similarly, if you have a minus here instead of plus, if there is a minus, I'll take that x squared minus 10x plus 25. Suppose if you have it this way, we change it to x squared minus 2 times that x. You know you're going to get 5 from here because 25 is 5 square. So that is 5. So what happened here? X square, 2 times x is 2x and 2x times 5 is 10x. We didn't change anything. We just got the factors of that 10. And of course that x is there. And 25 is written as 5 square. So your product form is going to be, factored form, x minus 5. X minus 5. It is minus x minus 5 whole square. That is a minus b whole squared. So we have to look for some trinomials if they are special kind like this. Square of the first, and then this is also a perfect square, the last term, and in the middle term, the second term is going to be twice the product of the first and the last. I am saying that 2 times. 2 times x times 6 is 12x. In this case, the middle term is 2 times x times 5, that is 10x. So look for such cases. Okay. Now, what if the given expression is not a perfect square trinomial? In this second example, we have a trinomial x squared plus 18x plus c. We don't have the value for c, but you are asked to find the value of c to make this trinomial as a perfect. So in this trinomial, c is missing. We are looking for the value of c. What is the value of c? So that this trinomial becomes a perfect square. Right? It is very simple. I'm looking for this number c. Okay. Like the previous example, we have 18. 18 is the sum of the two factors. Because you are looking for a perfect square, definitely my first number is half of 18. That is 9. I will write 9 here as my first number. Even the second is also going to be 9. 9 plus 9, 18. And the 9 times 9 gives you 81. So you have your answer. C is nothing but 81. C is equal to 81. Let us verify. X squared plus 18x plus that C is 81. Now it is of the form of what? A square plus 2ab plus b square. So my answer in the factored form is a plus b whole square. So your x is b is 9, because 9 square is 81. Okay, so I'll write x square a square, and okay, that's fine. And in the middle I'll have 2 times a times b, that a is x and b is 9. See, 2 times 9 is 18. Same thing. So I'll just write x plus 9 whole square. You can even verify. On multiplication of x plus 9 with x plus 9, the product is going to be x times x, x square plus x times 9, 9x plus this 9 times x, 9x plus 9 times 9, 81. So my product here is x square plus 9x plus 9x, 18x x square plus 18x plus 81. See, everything is around that, like from factor to product or from the product to factors. It is just we have to understand what is the thing here. It is nothing out of anywhere. Just everything is right in front of us, but we just have to figure out. Right? So in this particular case, my C is going to be 81. C is the answer. If you want, you can look at one more example. Let me take x square minus 24x plus a blank. What goes in here? How do you do that? Again, go back to our regular procedure, how we used to do to find the factors. Follow the same process like we did earlier. That is minus or negative 24. Half of the 24 is 12. 12 here, 12 there, 12 times 12. Of course, I can put a negative sign. Negative 12 and negative 12 gives you times on multiplication, positive 144. We know that negative 12 times negative 12 gives positive 144. Now, here in this blank, I should have 144, and my factored form using this second formula, it will be x minus 12 whole square. Alright. Okay, once you get this process, please try these two problems. Very simple. fill in the blanks, like given x square plus 16x plus blank here, fill in with a number so that this trinomial, this whole expression can be written as some blank plus blank whole square. In the same way, x square minus 2x plus blank is equal to blank minus blank whole square. So many blanks are there, don't get confused. It is as simple as that. X square minus 24x. You have only these two terms. So you divided 24 and did all that, no? Please try. Okay, thank you.